Hello everyone, welcome to the channel Code Like Him. Let's see today's problem. Longest subarray with the majority element greater than k. Given an array ARR and an integer k, the task is to find the length of the longest subarray in which the count of the elements greater than k is more than the count of elements less than or equal to k. So in this question we are given an array and an integer k equal k, and we need to find the length of the longest subarray in which in this subarray the count of elements greater than k is more than the count of elements equal to or less than k. Let's look at this example. The array is given as 1 2 3 4 1 and k is equals to 2, and the answer is 3. So the subarray is 2 3 4. So the number of elements greater than 2 are 3 and 4, which is 2, and less than or equal to 2 are 1. So 2 is greater than 1, so this is a valid subarray. So its length is 3, so the answer is 3. Or we can choose another array as 3 4 1. So the number of elements greater than 2 are 2, and less than equal to 1, less than equal to 2 is 1. So this is also a valid subarray. So first approach is we will find all the subarrays and count the elements which is greater than k, or count the elements which are less than equal to k, and then we will find the length of the longest substring. This will take big of n square, so which will not pass the solution. So what we can think of, we can use a prefix sum approach here. Whenever we find an element with sum less than equal to k, we will decrement this prefix sum, and whenever and else we will increment this prefix sums. If the prefix sum is greater than 0, it simply means that this subarray is a valid subarray because the count of elements greater than k is more than the count of elements less than equal to k, because only when the prefix sum is greater than 0. So we will simply have result equals to I plus 1. We will be storing the prefix sum in the map, and let's see this code here, what is it does, and we will be finding prefix sum minus 1 in the map. Let's look at this example here. The prefix sum will be minus 1 because 2 is greater than 1, so 1 is less than 2, so it will be prefix sum is minus 1. It is 2 is equal to 2, so it will again we will decrement this prefix sum. We will be having minus 2 here, and then for this element 3 we will be incrementing prefix sum, so we will have 1, and for 4 we will be incrementing again, so we will have 0, and for 1 we will be having minus 1. So prefix sum will be like minus 1, minus 2, minus 1, 0, and again minus 1. So the main logic here is we will be finding prefix sum minus 1 if it is present in the map or not. So this tells us that if it is present in the map, that from that index till the current index we will be having the count of elements k greater than k will be the count of elements greater than k will be more than the count of elements less than equal to k. That's why we are having plus 1 prefix sum. So let's say we are standing at prefix sum here. Let's look at this array 2 3 4. So 2 3 4, at the end of 4 we will be having prefix sum as 0. So we will find 0 minus 1. Where is this minus 1 present? So minus 1 will be here, minus 1, because prefix sum will be minus 1 here because 1 is less than 2. So we can see that 2 3 4, this is a valid subarray. Also we can say that let's say 2 3 3 4 1. So for this at when is standing at 1, the prefix sum will be minus 1. So minus 1 minus minus 1, minus 1 minus 1 will be minus 2. So we will be finding if minus 2 is present in the prefix in this map or not. Yes, minus 2 is present at this index. So all the elements after this index until the current index will be forming an subarray having the count of elements greater than k more than the count of elements less than equal to k. So this is the main logic here, and if the prefix sum is not in the current map, we will just store the current index as in the max against this prefix sum. So guys, if you find this video helpful, please like this video and share and comment, and please subscribe to our channel. It will be very helpful. Thank you.